Hey folks, welcome back. Video lecture 18. Last one of module 5, which means we have one module left after this. Pretty crazy. Today we're going to be building directly off of kind of our past 3 video lectures, but especially video lecture 17. We're going to be using our skills of factoring very heavily today. And we're going to be using those to help us solve these quadratic equations. All right. So a few topics in our stuff today. But first I want to practice factoring real quick. So I have a quadratic written down below. I would love for you to pause the video, go ahead and give yourself the opportunity to practice factoring real quick. So we have x squared minus 2x minus 15. Its leading coefficient is a 1, right? Our a is a 1 here, our b is a -2, our c is a -15. When our a is 1, our job is a little bit easier here. We don't have to worry about our b value getting messed with, but we want to create an x squared, so we need an x times an x. Okay. We think about our signs. We're going to be multiplying to get a -15. So to multiply to get a negative, we definitely need one positive and one negative. And then our list for 15, 1 times 15 or 3 times 5, we're looking for the set of numbers that would arrive at -2 when added or subtracted. And the ones that would do this are 3 and the 5. We would like to have it be +3 minus 5. If we're subtracting a larger number, it'll arrive at -2 rather than +2. So we want +3, -5. Okay, so we're going to be factoring more today. So the point of today's is something I'm going to ask you to notice about. So I took this expression, I put it into a graph on Desmos, and this is the graph that it gave me. Okay, so I just want you to take a minute, look at it. I want you to think about what you notice about the graph in relation to what we just did. Anything that you notice. Okay. So some people may notice, it has this kind of lowest point down here. That's a great thing to notice about a graph. People may notice the y-intercept here is in -15, and we're not getting into all this in this class, but -15, where was that? Oh, that was my c value at the beginning. That's crazy. Specifically, I'm trying to think about, based on how we factored it, is there anything there in relation to the graph? If we look at our x-intercepts, here, this x-intercept is at -3, right? -3, 0. And then this x-intercept is at 5, 0. And those directly relate, seemingly, to these factors that we have. They happen to be the opposite, but it's consistently the opposite, right? So we wrote x plus 3, and then our x-intercept ended up being -3, x minus 5. We end up having an x-intercept at +5. All right, so let's think about this as to why this is working real quick. What happens when I plug in these numbers, right? If I plugged in a 5 there, 5 minus 5 equals 0. That's what the y value is. And what happens when I plug in this -3? -3 plus 3 gives me a 0 out. So this is kind of what we're going to be playing with here today. So whenever we factor, what we are actually ending up working on is identifying where an x-intercept on this graph would lie. These are x-intercepts. We've done this before, right? Think about, what do we do when we're finding x-intercepts? Think back. What do we do? We set the y value equal to 0. We set the equation equal to 0, right? Back in the day, back in module 3, we were doing y equals mx plus b. We would set this output to 0. Yeah? We're going to be doing something similar here. So if we want to find an x-intercept, which is what we're going to be doing, we're going to be setting it equal to 0. Okay, so we are looking to find the x-intercepts. A few other words that you might hear of this is we're looking for the solutions to the quadratic equation. We're looking for the roots is another term that we might hear it called, okay? So now when we're looking for these solutions, when we're looking for these x-intercepts, we want the equation to be set equal to 0, okay? Get it set equal to 0 because then we can do this factoring thing. Now, what we've set up, I'm just going to rewrite what I've got here. When it's set equal to 0 and not another number, 0's got this special property, right? So what we have is we have a binomial, which is one thing times another binomial, so a second thing. We know that that thing times that other thing is equal to 0. How do we get 0 when we multiply? The only way that we end up with a 0 when we multiply is that something is a 0. And that's what we found. We had two places where it could be 0. So either this is 0 or this is 0. And that's got a special name. That's that multiplicative property of 0. All right. When we multiply and we want to get a 0, something has to be 0. Okay. In this case, we have two factors. We can split these apart and we can arrive at our two answers by finishing these out and solving the equations. So, right, this one we would subtract 3 on both sides. We would get -3 as our answer, which is what we saw in the graph. This one we would add 5 to both sides. We would get 5, which is also what we saw in the graph, okay? So as we work through these today, we're looking to solve the quadratic. We're looking for those solutions. We're looking for the roots, which are the x-intercepts graphically, okay? And the way that we're able to do that is through factoring, and these factors, as long as the equation is set equal to 0, will help lead us to these two solutions, okay? Something I want you to think about is how many solutions can I have? So knowing that the graph is this shape, right? We're not diving super deep into this, but it's worthy of noting. Knowing that the shape is like this, we've already seen that we can have two solutions, right? Do I have to have two solutions? The answer is no, you don't. If you had a quadratic where the graph was like sitting perfectly on the x-axis, so it just came down and just touched right there, this is one solution. And then you might also have another quadratic where it actually doesn't touch the x-axis at all. And we'd have 0 solutions. Okay. Predominantly here in this class, we're going to be looking for two solutions. So, but just a heads up, 124, 126 coming up quick. All right, let's try a couple. So the first two that we're going to try, we're also going to write down some steps as we do this. So notice that these ones, they are already factored for us and they already set equal to 0 for us. So we're just practicing kind of this new step. It's factored, it's set equal to 0. If we want to create 0 and we have two things multiplied together, the only way to create a 0 when multiplying is that one of these things are 0. So we get to split these apart, and it would be okay if this piece was 0, because if that's 0, anything times 0 is 0. It would also be okay if this piece was 0 for the same reason. You finish it out, you solve it, you would get y equals -8 as one of your solutions. You would get y equals 5 as your second solution, okay? All right, let's do one more, and then we'll write down some steps of what's going to be happening holistically here. All right, so we have a second one. It's factored, but you'll notice, we're going to have a leading coefficient that's greater than 1 here. But the same premise applies. Something times something equals 0. Thus, as long as one of these binomials would be equal to 0, the whole entire thing would equal 0. So let's finish this out, adding 2 and dividing by 3. We get 2/3 as an answer. So you notice that when we have a coefficient, right, when you have a coefficient that's not 1, it's likely that we're going to have a fractional answer probably. But this other one, I'm actually going to decide to add the v since the v is negative. And when I add the v, I get 3 equals v. Or if you want to write it the other way around, get 3. Okay. All right, so let's write some steps. So what we want to do holistically here is step one, we have to make sure that this thing is set equal to 0. We're looking for these solutions, these roots, these x-intercepts, okay? And to do that, they have to be set equal to 0. Same way we did with lines, okay? So we have to make sure that the equation equal to 0, okay? So if there's something over there, we need to move it. We need nothing on one side. Step two, if it's not factored, we need to factor it. Whatever method we need to use, we'll use, okay? Once it's factored, we're going to do what we just did there. We're going to set each factor equal to 0. And solve, okay? All right, so let's practice a few more and we'll send it on its way. So, all right, so let's identify what we've been given and what we might need to do. So we're given 3x squared plus 17x equals -10. And we've got our steps, right? We need to make sure we need to set it equal to 0. We need to factor it. We need to set each piece equal to 0 and solve. Do we need to set this thing equal to 0? Yes, it's currently set equal to -10. So we need to move that -10 to the other side. That's our constant term. So we're going to add 10 to both sides. We end up with 3x squared plus 17x plus 10 equals 0. Okay, so step one, we have it set equal to 0. Next, we need a factor. Various methods. So this one has a leading coefficient of 3. We want to see if we can actually factor out that 3. Is there a greatest common factor here? Anything go into all of those terms? Nothing goes into 3, 17, and 10. So we are going to just navigate that 3. We are going to make our binomials. We want to multiply to get a 3x squared. So 1 and 3 is the only thing that will do that. So that's nice. So we got a 3x and a 1x. Let's look at our signs. That's always the next step. We want to multiply to get a positive and add to get a positive. The only thing that's going to do that is 2 positives. And now we have our list for 10. So to multiply to get 10, we have 1 and 10 or 2 and 5. Okay. And now with this one, right, whatever number I put on this right side will get multiplied by 3. So let's think about what we might want to get multiplied by 3. Go ahead and give yourself a thought. You're trying to combine and make a 17, right? What'd you come up with? 3 times 5. 3 times 5 is 15, and that's paired with a 2. So 15 plus 2 gives us a 17 that we're looking for. Cool. So that's a good factor. All right, so we have our 2 factors, and now we're going to be able to use that multiplicative property of 0, where something times something equals 0. Thus, one of these things just needs to be equal to 0, and we would find a solution for each. Okay, so finishing this off, we're subtracting 2 on this left side, and then dividing by 3, we get -2/3. On the right side, we're subtracting 5 on both sides. We get -5 for our other solution. Okay, nice. Great job there. That is the most involved that you're going to see in this class. Okay, so just want to expose you to that right off the bat. All right, so we set it equal to 0. We factored it. We solved it. Moving on. Number 4. So what do you notice about this one? So step 1, it's set equal to 0. That's nice. Step 2, we need to factor it. What about factoring it here? What's going on? We have an A, we have a B. Our C term's kind of missing, so our C term is just a 0. That's fine, all right? But if we're missing our C term, we can't really ask any, right? What multiplies to get 0? It's just, like, if we're missing some important information here, okay? So always, right, anytime there's a leading coefficient, let's go and check to see if there's a greatest common factor. All right, so GCF, what goes into 3x squared and 24x? 3 goes into both of those things and x. So let's take out 3x and dividing by 3x, that's going to leave us with an x plus an 8. All right. We have two factors. They do look a little bit different than what we've seen, but here's a piece where an x can be input. So this is we can get a solution from this. And then we've got this binomial. So we're going to split these apart. 3x, when does 3x equal 0? And when does x plus 8 equal 0? This one on the left, we're just dividing by 3, right? And that makes sense. Put a 0 in, this whole thing would equal 0. That's great. And then if I put in a -8, this whole thing would also equal 0. So that's good. Cool. All right, number 5. All right, so we've got this thing. It's a quadratic, so that's cool. We're going to be looking for two solutions. We need to get it set equal to 0. And right now we have this, 15x. So we're going to subtract 15x from both sides. So we get 5x squared minus 15x equal to 0. Now let's factor it. Missing the c term again. So let's look for a greatest common factor again. 15x squared, or 5x squared and 15x. 5 goes into both, and we can take an x out. So dividing by 5x, we'd have an x minus 3. Okay. 5x, can that portion equal 0? Yes, there is a value of x that we could plug in to make 0. And x minus 3, let's figure out what works for that as well. All right, finishing out, we're divided by 5, we just get a 0. And add 3, we get a 3. And that makes sense, right? If we look at this first, right, if we think about plugging in a 0 to what we were given in the first place, right, 0 times 5, 0 squared, 15 times 0, it all equals 0. All right, one more. All right, number 6. So let's look at this thing. It's set equals 0. That's great. Factoring. We have a leading coefficient, so let's make sure we check for GCF. Does anything go into all 3 of these terms over here? Yes, a 5 goes into all of them. So let's factor out a 5. Make our factoring job a little bit easier. All right. Anytime you factor out something, it's there. Just keep writing it. Okay. We now have a quadratic where the leading coefficient's a 1. So that makes our job a little bit easier. We're trying to create an x squared, so we have an x times an x. We're multiplying to get a negative. To multiply to get a negative, we need one of each, 1 plus, 1 minus. And to make a 4, we got 1 and 4 or 2 and 2. Which of those are somehow going to make us a 3? It's a 1 and a 4. What do we want to be negative? We want to make a -3. We would like it to be a +1 and a -4. That would create the -3. Now, with the one that we've got here, it seems that we have 3 different portions, right? But we talked about how a quadratic, something with a highest power of 2, would only have 2 solutions at most, okay? So if we look at this piece by piece, this thing that we factored out front, this 5, can this 5 ever equal 0? Can a 5 equal 0? No. This 5 can never equal 0. There would not be a solution that comes from this portion, right? There's no x there where we can input a value to make it create a 0. So this number out front, it is, it's something that you'll talk about in a different class, but that right there will not create a solution for us. This binomial here, right, there is a value of x that we could find that would create 0, and same for this one. Okay, finish it out. We subtract 1, we get -1. We add 4, we get +4. All right, very cool. All right, I got one for you to practice before you come to class. Great job in these last couple of video lectures. So I want you to solve, so find the solutions for this given equation. And then as you're answering it, right, I want you to specifically be able to say, what do you know about the graph of this quadratic? Okay, based on what we talked about today. All right, again, great job. Keep up the great work. I'll see you next time.